Welcome to today's lesson on oxides and salts. So this topic is very short, but it's going to be delivered into two videos. So we're going to start with oxides. We're going to take a look at different types of oxides and their characteristics. Then we'll go to salts. We'll take a look at different types of salts and their characteristics, and also an important property of salts, which is solubility. The ability of a salt to dissolve in water. Then in the next video, we're going to take a look at different methods of preparing salts. Let's get started. So an oxide is just a compound which is formed when oxygen combines with any other element. So whenever oxygen combines with any other element, what is formed is an oxide. So there are different types of oxides. There are 4 types of oxides. The first is what are called acidic oxides. So acidic oxides are just oxides of non-metals, but actually this is not a good definition. Acidic oxides are actually oxides of let me just say that again. Acidic oxides are oxides which, when dissolved in water, form acidic solution. So if you have been given an oxide, then you dissolve it in water and it gives you an acidic solution, then that is an acidic oxide. Usually, not usually actually, all the time, acidic oxides are oxides of non-metals. So when a non-metal reacts with oxygen, what is formed? Usually it is an acidic oxide. As you are going to see later, there is another type of oxide that can be formed when a non-metal reacts with oxygen, but mostly it's acidic oxides. So here are examples of acidic oxides and how they are formed. So the first is carbon dioxide. So carbon dioxide, the formula is carbon and oxygen. Carbon is a non-metal. So when this carbon, a non-metal, reacts with oxygen, it forms the acidic oxide carbon dioxide. Then we have nitrogen dioxide. Nitrogen is non-metal. When it reacts with oxygen, it forms nitrogen dioxide. The same is true for sulfur and sulfur trioxide. So these are examples of acidic oxides. Next, we take a look at the properties or characteristics of acidic oxides. So the first characteristic of acidic oxides is that they dissolve in water to form acids from the definition. So here is the example. When carbon dioxide dissolves in water, it forms an acid called a carbonic acid. Carbonic acid, for those who like carbonated drinks, this is the acid that you drink. What is done is carbon dioxide is dissolved in water at high pressure, and what you have is carbonic acid. Then also we have another example is this oxide reacts with water to form nitric acid. So this is the behavior of acidic oxides. Then the second characteristic is acidic oxides react with alkalis to form a salt and water only. So these acidic oxides, they have a strange behavior or a certain behavior. They behave like they are acids since they are acidic oxides. So an acid, when it reacts with alkalis, it forms a salt and water. Remember neutralization. So even them, when they react with alkalis, they participate in a kind of a neutralization reaction which forms salt and water because they behave as acids. So here is an example. So we have sulfur trioxide reacting with sodium hydroxide. Sulfur trioxide is made of sulfur and oxygen, so it's an acidic oxide. Then it reacts with sodium hydroxide, which is a base. Then what is formed is sodium sulfate, which is a salt, and water. Again, sulfur trioxide reacts with calcium hydroxide. Calcium hydroxide is a base. What is formed is calcium sulfate and water. Calcium sulfate is a salt. Carbon dioxide reacts with sodium hydroxide to form sodium carbonate, which is a salt, and water. So these are the neutralization reactions that involve acidic oxides. The second type of oxides are called basic oxides, which are oxides that gives a base or an alkali when dissolved in water. So if you have an oxide, you dissolve it in water, it gives you an alkali or a base. Then that oxide is a basic oxide. So they are formed when a metal reacts with oxygen. Unlike acidic oxides, which are formed when a non-metal reacts with oxygen, basic oxides are formed when a metal reacts with oxygen. If you remember when we were studying periodic table, one of the characteristics of metallic compounds was that they react with oxygen to form basic oxides. So now things should be making more sense now. So here are examples of reactions of how they are formed, these basic oxides. So the first example is sodium oxide, which is written as Na2O. So the reaction is sodium, which is a metal, reacts with oxygen to form sodium hydroxide. I think this is sodium dioxide actually. Then we have copper 2 oxide here, which is of course with a valence of 2, so the formula is this. But how it is formed: copper reacts with oxygen to form copper 2 oxide. So here are the characteristics of basic oxides. First, some soluble basic oxides dissolve in water to form alkalis. So basic oxides, even just from the definition, when it dissolves in water, it will give you an alkali. So here's an example. Sodium oxide, it's supposed to be small 2 here. Sodium oxide reacts with water to form sodium hydroxide, which is an alkali. Also have calcium oxide, which reacts with water to form calcium hydroxide, which is an alkali. The second characteristic is basic oxides react with acid to form a salt and water only. So they also participate in a kind of neutralization reaction when they react with acids, because they behave like bases. So an example is this one: sodium oxide reacts with hydrochloric acid to form a salt, sodium chloride, and water. Then also have calcium oxide reacting with sulfuric acid, H2SO4 with sulfuric acid, to form calcium sulfate, which is a salt, and water. Then the third type of oxides are called amphoteric oxides, which are just oxides that display both acidity and basicity. So they are formed when metals react with oxygen. So from the definition, amphoteric oxides, they behave as acids and also they behave at the same time as bases. Therefore, they can react with acids when they are behaving as bases, and they can react with bases when they are behaving as acids. So they are formed when metals react with oxygen. What else is formed when metals react with oxygen? It's a basic oxide. Yes, basic oxides. So there are special types of metals that form these amphoteric oxides. Usually it's the transition metals and the semi-metals, the metalloids. Most of them form amphoteric oxides. So here are some examples. So zinc oxide, which is part of the transition metals, the formula is ZNO of the oxide, and the reaction zinc reacts with oxygen to form zinc oxide. Aluminium oxide, the other one. Actually, this is one of the famous examples. So aluminium oxide is written like this, and aluminium reacts with oxygen to form aluminium oxide. So aluminium, which is a metal, reacts with oxygen to form this amphoteric oxide. Then we have lead 2 oxide, which is written like this, and lead reacts with oxygen to form lead 2 oxide. So these are how amphoteric oxides are formed. What are the characteristics of amphoteric oxides? So the first characteristic involves how they react with acids. Again, so the reaction is a neutralization reaction. So these are the examples. Zinc oxides reacts with hydrochloric acid to form a salt, zinc chloride, and water. Aluminium oxide reacts with phosphoric acid to form aluminium phosphate and water. So this is a salt. Even here there is a salt and water. So when they are reacting with acids, they behave as bases. They act as bases. So in this case, they are bases. They are reacting with acids in a neutralization reaction to form a salt and water. Then the second characteristics is how they react with alkalis. So when they are reacting with alkalis, they behave as acids. So again, it's a neutralization reaction. So the first example is zinc oxide. In this case, it is an acid reacting with sodium hydroxide to form this compound here, this salt which has a special name, and water. So this is called sodium zincate. Sodium zincate. Then we also have aluminium oxide reacting with sodium hydroxide to form this salt and water. So this salt also has a special name. It's called sodium aluminate. Finally, we've got this example where I've got lead oxide reacting with sodium hydroxide to form this salt and water. So this one is called sodium plumbite. So these are examples of neutralization reaction in which amphoteric acids behave as, amphoteric oxides. I wrote amphoteric acids instead of oxides. Yeah, so this is an example in which amphoteric oxides behave as acids and they react with alkalis. Finally, we have neutral oxides. So neutral oxides are oxides that do not show either basic or acidic properties. Neutral oxides, they do not react with bases or acids. They do not behave like amphoteric. They are opposites of amphoteric. So actually, I'm not going to study any characteristics of neutral oxides because they do not react or participate in any neutralization kind of reaction. So neutral oxides are oxides of nonmetals. What else is an oxide of a nonmetal? Acidic oxides. So there are some nonmetals that form neutral oxides. Here are examples. Carbon monoxide is a neutral oxide. The formula is CO. But remember, carbon dioxide, it is an acidic oxide. But carbon monoxide, it is a basic oxide. It is a neutral oxide. Okay, the only difference is in carbon dioxide there are two oxygens. In carbon monoxide there is one oxygen, but the properties in terms of oxides, they are different. Carbon monoxide is neutral oxide and carbon dioxide is acidic oxide. The other one is nitrogen monoxide. The other one is water. Okay, so water is an oxide also. Okay, hydrogen reacts with oxygen, so it's an oxide, and its chemical name is, okay, it has other chemical names which are interesting, but here it's hydrogen oxide. But you can also call it the hydrogen oxide. So with that being said, then we have the nitrogen oxide here. Wow, I'm from saying the hydrogen oxide, then there's the nitrogen oxide here, which is N2O. So these are some neutral oxides. Then we take a look at salts as we conclude this lesson. So a salt is just a chemical substance formed when the hydrogen ions in an acid are replaced by a metal or ammonium ions. So if there is a reaction involving an acid and that acid has been, and the hydrogen in that acid has been replaced by a metal or ammonium ion, then what is formed is a salt. Here are some types of salts. So the first type of salt is called a normal salt. So a normal salt is just a salt formed when all the hydrogen ions in an acid are replaced by metal or ammonium ions. Okay, so when all the hydrogen ions are replaced by a metal or ammonium ions, then we have a normal salt. Here are some examples. So here, sodium hydroxide. We don't care about sodium hydroxide. We have hydrochloric acid here. So this hydrochloric acid has hydrogen here. So if this hydrogen is replaced by a metal in this reaction, then what we're going to have is a salt. So at the in this neutralization reaction, of course, where hydrogen was, there is nitrogen. There is sodium. So this sodium is a metal. Okay, so it has replaced the hydrogen, so this is a salt. According to the definition, what we have here, when the hydrogen ion in the acid has been replaced with a salt, we have has been replaced with a metal or ammonium ion, then we have a salt. So this is a salt here. Another example is the reaction between the metal calcium and sulfuric acid. So in this reaction, calcium and sulfuric acid, the hydrogen here are replaced by calcium. So we have calcium sulfate. So this is a salt because the hydrogen ions have been placed by a metal. So here are some examples of normal salt. No need to master them. There are just some common names here, like sodium chloride is called common salt or table salt. And then we've got calcium sulfate, sodium sulfate, which is called Glauber's salt. Of copper 2 sulfate, calcium carbonate, which is called limestone or marble. This one you should at least have it in your mind. This one and this one, but it's not a big deal. Then I've got magnesium sulfate, which is called Epsom salt. The second type of a salt is an acid salt. For salt, we have two types. We have a normal salt and an acid salt. So an acid salt is a salt which is formed when part of the hydrogen ions in an acid are replaced by a metal or ammonium ions. So let's say there are more than one hydrogen ions, then just some of them have been replaced, but some are remaining. Then what we have is an acid salt. It is a salt which has the hydrogen ion in it. So it behaves as it has some acidic properties. So here are some examples of acidic salts. Here we have potassium hydroxide reacts with sulfuric acid. So this hydrogen here, there are two hydrogen ions. So the potassium just replaces one hydrogen ion. So we have this. Out of these two hydrogen ions, one has been replaced. So we have potassium and hydrogen. So in this case, what we have here, it's an acidic salt because it is a salt, but it still has hydrogen in it. Then we have also this one, which involves ammonia. So this is ammonium hydroxide. So reacts with sulfuric acid. The two hydrogen here, one of them has been replaced by ammonia here. So we have ammonia taking the place of one of the hydrogen ions. So, but still we have one hydrogen ion remaining here. So this is an acid salt. So normally the names of acid salts, you are going to find that they have hydrogen in them. For example, this one is potassium hydrogen sulfate. Then this one is ammonium hydrogen sulfate. I'm not sure. Yes, but it's something like that. They usually have hydrogen in the name. So that hydrogen reminds you that there is a hydrogen ion inside. Finally, we look at solubility of salts. So this is a very important thing to study. We need to know which type of salts are soluble, because by knowing the solubility, then we can know how to do with them. We can know how to prepare them and the likes, as you're going to see in the next lesson. So here are some salts and their solubility. Even the reaction that involves salt, sometimes in an exam they will describe a salt. A salt is soluble, then you should be able to tell which salts are soluble. So all nitrate salts are soluble. Okay, so if they say sodium nitrate, calcium nitrate, they are all soluble. So long as they have the word nitrate in them, then they are all soluble. Then the second types of salts are chlorides. So all chlorides are soluble except silver chloride and lead 2 chloride, which are insoluble. So whenever you see chloride, you should know that it is soluble, apart from silver chloride and lead 2 chloride. Other lead salts are okay, but lead 2 chloride is not soluble. Then we have sulfates. All sulfates are soluble except barium sulfate and lead 2 sulfate, which are insoluble. Calcium sulfate is slightly soluble. So for sulfate, all of them are soluble apart from barium sulfate and lead 2 sulfate. Lead is usually a vigilante, so even here it was insoluble. So even here when it combines with sulfate, it is insoluble. Then calcium sulfate is slightly soluble. Okay, so these are the things to master. Then finally, carbonates. All carbonates are insoluble except potassium carbonate, sodium carbonate, and ammonium carbonate, which are soluble. So whenever you have a salt and it has the name of carbonate, then know that it is not soluble, apart from these three: potassium carbonate, sodium carbonate, and ammonium carbonate. So this concludes our topic. I hope you have enjoyed, and happy solving.